Okay, so for PwnKit, um, as I mentioned, it is actually a vulnerability um, of a package called Polkit, or Policy Kit in short. And yeah, it is discovered by this researcher Koalis in January. So it's like about 4 or 5 months ago. It's actually very famous, and yeah, I have the repository uh, of Pocket here. So, fun fact: what's a bit funny is actually this uh, vulnerability, or at least the code that's vulnerable, has been around since about 10 years ago. So yeah, so it's been it's been basically uh, on a lot of the Linux distribution for the past 10 years, but yeah, it was just discovered early 2022. So in Pocket, there's a couple of executables, or yeah, programs. One of them being pkexec. Now, pkexec is actually somewhat similar to sudo. Basically, it gives, yeah, executes a command as another user. It gives privilege to, the unprivileged programs. So yeah, very similar to sudo. Now, maybe let's just before we jump into the source code, which is here. Wait. Um, I want to uh, talk a bit about arguments and environment variables, um, especially in C programming language and CLI, um, CLI applications. So um, hopefully this is big enough. So yeah, in C, we can actually, usually when we want to execute, let's say, a CLI program, let's say something like cat, we first type the name of the program and then the arguments, or yes, stuff like options, and a file or anything after the name of the program, right? So let's say, for example, for cat, let's say you want to print out content of a file, we type in cat as our first argument, and then we follow up with the name of the file as the second argument, and we can see the content of the file. Now, in C specifically, these inputs taken in by the shell is actually tokenized and received as tokens. So, for example, cat argc is received as two tokens, cat and argc. Now, in terms of the C language, it is actually passed into C into a variable called argv. So, well, not a variable, basically a pointer. So in C, let me just open this in the editor. In C, argv and argc are basically, argv is the pointer. It points to the memory where the arguments that we actually type are, and then argc is just the amount of arguments. So, for example, let's say, I have built the binary already for this program, but let's say we type in args, and then let's say test1, hello, cool, awesome. Now then we can basically read the arguments from a C code. If you take a look again at the code, it's just really basic. It's just a for loop that runs argc times, and then it prints out the value of that the pointer points to argc, right? So what's interesting is usually in CLI programs, well, not just CLI programs, but in CLI programs, it's not just arguments that are taken into account to actually build out, let's say, programs that can, operate a lot different kind of stuff. Besides arguments, there are also environment variables. Now, environment variables are often used for different kinds of things. There are many different kinds of things. Let's say, for example, we have a very common environment variable called PWD. PWD as in short for basically the current working directory. I forgot the exact abbreviation, but yeah. So these environment variables are usually also used in CLI programs or any kinds of programs to change the behavior of the program, right? Now here I have another C code that actually shows that arguments and environment variables are actually stored in memory side by side. So let's say just like I did before, let's say I do cat argc. Now these two are arguments because we type into the shell. It will be stored into the memory on these two index, and then after that, after the null block, then there will be the environment variables. The environment variables being things like, as I mentioned before, let's say PWD, or let's say term, all the environment variables we have on our shell. So to prove this further, I've actually took a C code that actually basically is we have a variable with a dot here, and then we have a pointer pointing there, and we have an infinite loop. Now the infinite loop will basically print out the contents of the memory it is pointing to if it is not null. So if it's null, we will just enter, because obviously if you print null, there's nothing to be displayed, we can't see anything. But if it's not null, we want to print out, flush it out, and then we want the pointer to keep moving to the next allocated memory. So if you actually do this, we can actually see. Now let's put some arguments here. Now we can actually see the arguments we've inputted is included. The first argument is calling the binary, and then the arguments we type separated by space, and then here we can actually see the environment variables we have. So hostname, PWD, home, ls, term, and path, etc. And then until we hit segmentation fault, when the pointer tries to point memory outside of our process. So now once we have understood arguments and environment variables specifically for CLI programs, it is stored as follow like this. You can actually now continue to reading the source code of pkexec, right? So pkexec, I have the source code here from GitLab. Now we want to focus on a couple of specific sections only. So for example here, we have a for loop that runs through the arguments of pkexec. So things like --help, can see here string compared as a shell, this is version and all that. And if we scroll down, there's actually something very interesting here, where basically here we can see we have variable path that takes in string duplicates an nth variable argument. Now, if we scroll down a little bit more, we can also see here something a bit odd is that then we assign an nth argument variable with the value s, right? Now you might wonder, why are these two important? Well, by this we actually know that let's say if we input null as our first argument, so if we open up the picture here, if we input null here as our first argument, sorry, wrong tab. First, yeah, okay. Basically, if we put null as our first argument, we are able to read and write environment variables through this program. Now let's run through the code on how can that happen. So we'll start off with this for loop again. Obviously this for loop won't be executed, but we have to remember that n is equals to 1. Now we go back to the variable we've mentioned before. Path is equal to argument variable with index 1. And this actually reads out, if you open this, if you open the drawing here, let's copy this, paste this, and let's say we have null as our argument, and then we take these to the left, right? Now then we're actually not reading an argument, rather than we're reading an environment variable. So this is path, right? And yeah, this is actually one of the vulnerability that but another really interesting thing here is that here, as I mentioned before, argument v_n, so argument index 1, and then we assign these variable into it. So basically we are reading and writing an environment variable through this program. Now then we might ask, what's really, why do you want to set environment variables to a process, right? I mean, isn't that something that we can do easily? Now environment variables, they are actually really important environment variables. There's something called unsecure environment variables here in glibc, where if someone managed to set these environment variables, the user can easily easily do privilege escalation. Now, however, these unsecure environment variables are actually filtered out, so you cannot actually set these unsecure environment variables without exploit like here in pkexec. So we can actually set, let's say, one of these unsecure environment variables here, right, to actually get privilege escalation or get root. is your root. However, if we scroll down a little bit, we stumble upon this line of code, clear ANV, which basically clears out all of the environment variables. So even if we manage to somewhat set an unsecured environment variable through this program, we the environment variable will actually be just clear a couple lines after where is it? Yeah. Here. So long story short, what we want to do is we want to find something between find something before clear env and after this line here where we actually write to the environment variable. So you want to find some exploit between these two, because as I mentioned before, all environment variables will be cleared here. However, with this we can write any environment variable we want, including unsecured environment variables that are usually filtered out by glib. So the researcher of this vulnerability actually found out something interesting here. So if you take a look at this function, validate environment variable, just copy this and then paste that. We can see here is the function. Now if we scroll down a little bit, this basically checks this section basically checks for our shell environment variable. Now these two sections are what we want to focus at. The gprint error is a function that we can actually use to gain root access. Yeah, maybe you're wondering how. So I have a drawing here. So gprint error is actually a library from glib, and basically in the program it actually checks if our char set environment variable is set to UTF-8. If it is actually set to UTF-8, it will display error. However, if it's not, it will call something called icon view open, and then icon view open will call conf_mod, and then conf_mod will actually try to convert the input that's not UTF-8 with a certain module, and then after that, then actually print the error. So what's really interesting here is conf_mod actually use an environment variable called gconvpath, which basically finds the module used to convert the input, the gprint error input, right? Now the module here is actually executed as root here. So this is basically what we're trying to exploit here. We want, as I mentioned before, with this line of code, if you scroll down, we are able to write any environment variables we want, including unsecured variables. Things like LD payload, even R, it is included here also, gconvpath. We can write any environment variables we want. In this case, we want to write gconvpath environment variable to actually run a module as root to print the error. So here, maybe what we want to do is something like, okay, we give gconv path a path to quote unquote a module or our exploit. Okay, pawn, then it will run pawn as root, and inside pawn we can do anything we want. In this case, we want to give ourselves a root bash shell. So let's jump into the code, the POC. So here, let's open the PwnKit first. So this is a POC with someone, but yeah, basically we want to set our argument variable to null, so that we can read and write environment variables to pkexec. And then for the environment variables, we want to set a couple environment variables here, right? So if we open the source code again, as I mentioned here, we want to write an gconv path environment variable to this line of code. However, to actually write gconv path environment variable, we have to make sure that the variable s, which is which runs this gfind program in path, actually returns the text gconv path equals to a directory containing our exploit. How to do that? We actually have to set our first environment variable to pawn, and then because the first environment variable will be assigned to the variable path, right? So path will be equals to pawn, and then pawn will be passed into gfind program in path, and then gfind program in path will use another environment variable called path to actually find pawn. So that's why if we take a look here, we write pawn, and then we set path to gconv path dot. So then this function will actually return something like this. Okay, let me erase that. Oh, sorry. It will return something like returns gconv path dot slash path. Now this is what we want. This is the environment variable we want to write to, and then yeah, obviously then this s will be written into the first environment variable to this. So yeah, that's why we want to set pawn as our first environment variable, and then we want to set path to gconv path dot. However, we cannot just set the environment variable to path. We actually have to have this directory and this executable for this function to return gconv path dot pawn, right? So what we want to do is here, we want to make there gconv path equals to dot, and then inside gconv path, and we this first. Inside gconv path, we want to hash pawn, and then oh, So now we have gconv path containing pawn. This function should return gconv path dot slash pawn. Okay, so if we get back to the C code here, then we also want to set the environment variable term to dot dot, because as I mentioned before, in the function where is it, validate environment variable, we want the function to actually execute this block right here, gprint error, to actually trigger this exploit, right? So by doing that, we set environment variable term to dot dot, so it gets into this else if block. So by doing that, now we're actually able to call gprint error. We use these two to set gconv path environment variable, and then I have yep, this is basically just to show you basically if it's not UTF-8, it will call this function, which will call another function, which will end up is calling convmod, and then yeah, convmod will call gconv path environment variable to find the module. Now what we want to do next is we want to create the pawn directory. We want to create the pawn directory, and then inside the pawn directory we want to actually create a gconv module, because now this directory will be considered as a gconv module by the convmod we discussed before. So to do that, there are a couple of files and default method that we want to implement. But the first thing we want to do is we want to create gconv strip modules, and then inside gconv strip modules we want to basically type in module utf-8 / hello / conversion mod, or something like this. Let me check if this is actually correct, because I don't really remember. Let me check my notes. Oh yeah, I'm gonna do something like that. Yeah. So we tell that it's a module, and then so now that we've set gconv modules, now what we want to do is we want to basically just execute any C code you want in that module. So this gconv modules file will actually call the conversion module code C code binary .so file, and in this uh, in this .so file we actually set UID 200, and yeah, basically we spawn a root shell, and now we are root, something like that. So yeah, now what we want to do is basically compile the conversion mod.so. So gcc to .so file, slash conversion mod.so conversion mod.c. So if you check inside Cron, we have that conversion mod ready. So now supposedly if we where do I have the PwnKit compile? Let me check everything. Okay, I haven't compiled the main C code, so okay. Wait, sorry. So now if we run the binary that we coded up before, let's just see for the last time. So these two to set gconv path environment variable. This is to basically trigger the gprint error, because as I mentioned before, in this graph we don't want it to be UTF-8, so we put in anything other than UTF-8. You can actually maybe just put like something gibberish there, but I just turns out to put hello, and then yeah, and then basically later it will look out for the module with gconv path environment variable, which is this pawn right here, which is this pawn folder, and then in the conversion, not conversion mode, and gconv modules, we actually say that, oh okay, I can convert hello to UTF-8 by running conversion.mod. So now if everything is working, I should be able to get root. So yeah, here I am root. Let's click ID, I am root. So yeah, this is actually a very interesting exploit. I learned a lot. It took me a while to understand the flow of pkexec itself, but yeah, I think this is very interesting. Hopefully everything is clear enough. Maybe one thing I forgot to mention is, wait, let me get out of this, is yeah, after setting the environment variables, then we want to execute pkexec with the arguments and environment variables we have set up. So yeah, hopefully if this is clear enough. Share ideas if anything's unclear. I am happily I can have I would love to clarify, or maybe I don't know, maybe create another video, or maybe create a documentation if needed. But yeah, hopefully you enjoy my explanation, at least my attempt to explain this beautiful exploit. I learned a lot, and yeah, this makes me actually want to learn more about low-level language like C and Linux OS kernels and all that. Understand what's behind all of these abstractions. But yeah, enough of my rumble here. Thank you, and yeah, hope you enjoy. Bye bye.